Unit Operation Classroom. We are now discussing GATE 2023 question 12. The vector is defined by this expression here. Which one of the following is the correct value of the divergence? We have to find out the value of the divergence evaluated at a certain point. Very quickly, the divergence of a vector in general, so this is a generalized expression of the vector, is given by this del dot v vector is given by this expression here, which is basically a derivative of the I component with respect to x, and j component with respect to y, and the k component with respect to z. Remember that the divergence of a vector is a scalar. So this is a scalar quantity. As you can see, each individual item is a scalar quantity. So intuitively, what is this divergence? Before we actually solve this problem, if the divergence value is positive, then there's a net outflow of a fluid. As for example, very simply, let's say water is flowing out of a tap. At this particular point, the divergence, of course, is going to be positive when there's a net outflow of a fluid at a particular point. Similarly, if there's a negative value of the divergence, net inflow to a point, as for example to a narrow sink. So there is, let's say, narrow sink. So at this particular point, so there would be a negative value of the divergence. And if, of course, the value of the divergence is equal to 0, which is usually the case of an incompressible flow, let's say like water, any liquid, there is no expansion or contraction. Again, let's say this is a conduit and through which air is flowing. So if there is a spot heating here, so there will be an expansion of air at that particular point. So here the divergence would be equal to positive, as we said, net outflow of a point. Similarly, if there is a cooling here, spot cooling for some reason, then the divergence would be negative, right? Okay. So let's see what are the applications of divergence of a vector in chemical engineering. We know for a continuity equation is given by this expression here, usually for like transient, that is time dependent mass balance. We write this equation. If an opportunity comes, we'll show you how to use this particular equation. So this, of course, is the divergence of the mass flux, because here's the density. Okay, so this is the divergence of the mass flux right here, and it's the variation of density with time. Therefore, for compressible, let's say for air, any gas, for compressible steady flow, this, of course, time dependent, the transient term would be equal to 0. So this would be equal to 0, where, of course, the density will remain inside the parenthesis. That means that it would be a divergence of the entire mass flux would be here. And that would be equal to 0. That is my continuity equation. If it is an incompressible, let us say like for water or any liquid, whether this is steady or unsteady, because since the density does not change with time, so this would be equal to 0. So therefore, in those cases, for compressible flow, then of course we can say, and of course this density term can come out here. So we can just say that the divergence of the velocity vector itself equal to 0. That is only for incompressible fluid. And if, let's say, if there is a steady state compressible flow, it may be some kind of a chemical reaction, then of course this divergence would be equal to, let's say, a mass generated, maybe per unit volume, maybe due to reaction. So with that basically very brief insight, let's try to solve the problem. This is the vector given, and as we say, by definition, the divergence of this particular vector is given by this one right here, and this is of course my P, and this of course is my Q, this is my Q, and this of course is my R, right? If we take the derivative with respect to x, we get z. If we take the derivative with respect to y, we get 2x. If we take the derivative of this one with respect to z, we get 3y, and we put these values, we get the value of 13. Okay, so basically what is happening, like as I discussed, so here the divergence at that particular point is positive, so there might be more flux of masses leaving than entering, which could be, might be like there is some kind of a decomposition reaction. That means there is an increase in the number of moles due to reaction, or there could be a phase change, something of that sort. Of course, that's not really asked in this problem. I just wanted to give you an insight of this particular problem. Okay, so this value is equal to 13. So, so of course, D is going to be the correct answer.